We've all been there. You make a stream layout with a bunch of sick graphics, awesome stinger transitions, rotating lower thirds, webcam frames, all of that, and everything seems peachy. You launch your game and go to stream, and suddenly you have a ton of render lag or even encoding lag. Your stream just isn't running the way it's supposed to. The likely reason? Your media sources aren't optimized for OBS. Unfortunately, there isn't such a thing as optimizing your media sources for OBS, but in this video I can help you identify the proper formats that you need to be using for your graphics and for your overlays and stuff, especially if you are on a lower end computer and are more CPU bound than, say, someone like me on my main machine with the freaking Threadripper. If you're back here on something more like a Ryzen 3300X or an older school Intel, this video is for you. I'm EposVox, the stream professor, and today's video is a nerdy deep dive on the supported formats and hardware accelerated decoding, alpha channels, things like that for your OBS graphics. Because while it seems all fairly straightforward from the get-go, it really isn't, and a lot of performance problems come in from using codecs that don't necessarily play nice with your computer, depending on your machine. And a lot of people who just have higher-end hardware never really notice it, and a lot of people who have lower-end hardware fight this battle every day. So the core problem that we're addressing here is that stinger transitions, the transitions that come over with, a graphic like you saw at the start of this video that takes up the whole screen and then changes scene in the middle of it, hides the transition behind it, things like that, with an alpha channel or other graphics with an alpha channel, such as a lower third, a webcam frame, and so on, have a layer of transparency baked into the format. And these kinds of graphics can really bog down your system or cause you performance issues for your live stream. The second problem, which is the problem within OBS itself, is that there are no formats with alpha channel or transparency that have hardware accelerated decoding, which means that it's sped up by your graphics card, for example, within OBS or FFmpeg in general. There's just no formats that have both alpha and hardware accelerated decoding at the same time. This was kind of a tease because in a recent update to OBS, they added hardware accelerated decoding support for stinger transitions. But again, it's only for the codecs that support it, which aren't any codecs that are really usable that have alpha support. So an example of this kind of contrast here is that both H.264 clips or VP8 or VP9 WebM clips that you may have acquired, for example, from our sponsor, Nerd or Die, when they don't have alpha transparency, are hardware accelerated within OBS if you have them selected, and can be played back really fast because it decodes on your graphics card and you don't even notice the impact. However, those same formats with alpha transparency are no longer hardware accelerated and will have a much higher impact on your system due to having to decode that on your processor, which again, if you have a processor that's well above the means of what you're trying to do with your stream and your game, and especially if you're using GPU encoding, then you may have never noticed it and it not be a problem. But if you try to switch to CPU encoding with X264, or you move to a lower end system, suddenly this problem might rear its head and really confuse you why you haven't had that problem before. I also real quick want to note the differences in the media sources within OBS itself, because there are media sources, but then if you have the VLC media player installed on your system, you also have access to a VLC media source. Now this media source is really powerful in that it has various playlist tools and kind of more advanced tools for managing what different media sources play in a given source listing and things like that. But it comes at the sacrifice that it doesn't have alpha support at all and doesn't have hardware accelerated decoding support. So you're trading off both of those for the playlist controls and things like that. The straightforward media source is the only one that has either or both of these things. I also wanted to note that in your media source properties, you can check the box for hardware accelerated decoding for any media source. It says use when available. That doesn't mean it's always actually being used. Now, typically when someone makes graphics for you or provides them to you, especially from a site like our sponsor Nerd or Die, when you get a graphics package from them, most of the overlays, the stuff with alpha transparency, are put together in a format called WebM, which is the container, which contains usually either VP8 or these days VP9 as a video codec. And this is a newer open source video codec from Google. However, in recent years, you've been able to kind of hijack it to implant alpha transparency into it. Technically, VP9 and VP8 do not actually support alpha transparency out of the box, but you're able to hack it in somehow. I don't really know the answer to this. I just know that you can make it work even though it's not supposed to be supported, which is why the hardware accelerated decoding doesn't really work for it. But using programs like, I think in the past in my OBS masterclass, there was a WebM program that you used, or there are plugins for Premiere and After Effects you could try to use as well, although I have trouble getting alpha to work with those. you can create VP9 files to then use, and those are typically what are distributed for OBS stream graphics because they're super small and lightweight in terms of file size, which is great if you're having thousands of people download them. But the problem is that they are a little bit tougher to decode, which is why it's always confused me why this codec in particular was used, especially without the official support in the first place. So my first guess whenever I tried looking at this problem has been to look into mezzanine codecs. These are beefier file sizes that typically decode or play back and seek on a timeline, like when you're video editing, very fast and very efficiently. And these include ProRes, typically on Apple, but now much more widely supported on Windows in recent years. DNx HR, which is typically more the Windows or Linux workflow, and then GoPro Cineform, which has risen in popularity in recent years. The Linus Tech Tips workflow has relied on it in the past. I don't know if they still do. I actually use it quite heavily because it has a little bit of GPU acceleration on Windows in specific programs, and otherwise is a little bit less bulky than ProRes or DNx HR, but works really, really well and works both in Premiere and Resolve, whereas with ProRes and DNx HR, I have kind of back and forth compatibility issues sometimes. The problem is that FFmpeg doesn't really have much DNx HR support, hardly at all, and it does have in recent years Cineform support in some capacity as it's been added as Cineform has actually gone open source. However, it's still very young and not super great, especially in the versions of FFmpeg that OBS supports, and you end up with a lot of issues trying to actually work with it when it comes to making the files or decoding them, and the results aren't super great. So what should you actually use as your graphics file format for OBS when it comes to stingers and things like that? Let me just say, y'all ain't gonna like the results that I've come to. For a full scene graphic like an intro, a be right back screen, a starting soon screen, things like that where you don't really have any alpha transparency, yet it's a non-alpha video file that takes up your full 1080p canvas or whatever, H.264 or VP9 is actually still best because both of those without alpha have hardware accelerated decode and will have a small file as well, which gives you both the best performance and easier, file sizes to manage. That's only for non-alpha graphics. For alpha stuff, I've actually found that the best option all around has been to be lossless AVI. Yes, like if you're making something in Adobe After Effects and you export it, natively because encoding in After Effects is dangerous, you go to lossless AVI and get a file that is massive. That has been the best performing result for smaller individual graphics pieces that I have found across a wide variety of hardware, especially if you're CPU limited. If you're on a beefier CPU with more headroom available while you're gaming and streaming, ProRes with alpha, as long as it's an 8-bit, gets much faster playback through FFmpeg and through OBS, and works great with quite a bit of a smaller file, although still a beefy file, much smaller than the lossless AVI. So on, i5s or i7s or higher, Threadrippers especially, Ryzen 5 3600s kind of CPUs, as long as you're not running a fully CPU bottlenecked game, ProRes with alpha is probably the way you want to go, which is great because you can encode that both with FFmpeg through open source programs or like StacksRip, for example, or with Adobe Media Encoder. So there is native support baked in to various programs. You do have to use ProRes 444 with alpha, but if you set it to 8-bit with alpha, works great. However, the CPU usage is a little bit higher here than, lossless AVI on CPU limited scenarios. Before we start talking numbers, we need to talk sponsors because this video would not be possible without our lovely sponsor, Nerd or Die, whose graphics, of course, we are focusing on here. I don't want it to come off as if I'm complaining about their graphics in this video, because in fact, it is the opposite. I am focusing on them and how they distribute VP9 because they provide such wonderful graphics packages for streamers, and my community has come to embrace them and use them in all of their streams and things like that, and it has been wonderful to see. They offer a wide variety of full stream packages for alerts, overlays, widgets, webcam frames, chat boxes, stinger transitions, social media icons. They actually just added some new free Twitch panels, a lot of things like that. And if you pay a little bit extra, they do include the entire source file in Adobe After Effects for you to modify and make your own versions of the graphics, which also means you can render them out yourself that way into lossless AVI anyway if you're making changes. So head on over to eposvox.gg/nerdordie and use coupon code EposVox at checkout to save 15%. Let's talk numbers. I do want to note before we talk performance that this these beefier files pretty much require, in most scenarios, that your graphics files are stored on a solid state drive, which is going to be painful for some of you due to the fact that the graphics themselves are going to be very large. For example, this 302 kilobyte VP9 Stinger transition I got from Nerd or Die when I used a script, which I will have linked in the video description. There will be 2 different ones. We'll talk about that at the end. When I used my script to extract that out to an AVI file with lossless with alpha, it turns into almost a gigabyte at 949 megabytes. Naturally, that is a massive inflation of file size, and for those of you who only have a small SSD paired with a bigger hard drive or something, that can be very difficult to manage. If the graphics are the only thing stored on your hard drive and your game isn't stored and you're not recording to your hard drive, theoretically a spinning hard drive could still work in this scenario, but I'm not going to recommend it in most cases because the data rates here are going to be massive. The AVI file for this is at 2.15 gigabits per second, which is faster than most of your hard drives are going to be able to pull. That's a pretty high data rate. This is also why I only recommend using lossless AVI for smaller individual graphics, because when you kick it up to a full screen file, even on a beefy computer, the throughput is just not fast enough to load data that quickly to play a scene, and it just plays back in slow motion. Talking performance, to test my CPU limited bottleneck scenarios, that was a lot of words that didn't necessarily go together. I was using my budget streaming rig here, which I have talked about a couple times, which consists of a Ryzen 3300X, a quad-core processor, 16 gigs of RAM, and a GTX 1660 graphics card. We tested a few different games, one of the CPU-heavy ones being Apex Legends here, and running OBS on it. And I was testing the different formats. I would switch all of the graphics in a scene. So I had a gameplay with a webcam scene with a lower third, I had a stinger transition, I had a full intro scene, and a full webcam scene, and would test monitoring the CPU usage and GPU usage as I switched between scenes with the different formats selected. Now, the full intro scene, just playing the intro clip, I got the best results, like I said, just using H.264 or VP9 because it doesn't have alpha. It then can use hardware accelerated decoding and had no performance issues whatsoever. The stingers and the lower third graphic are where we ran into trouble. Now, I found that lossless AVI for those smaller graphics had the best result at it, as it had the least impact on your CPU performance because it uses very little CPU to decode. It is this lossless AVI technically doesn't even have a codec. Like, as far as FFmpeg is concerned, this is raw video in RGBA. Like, there's no decoding to be done. It just plays the video file. Whereas every other video that has a codec has to then be decoded to raw video for your CPU to look at and then put into OBS. And so with lossless AVI, there is basically no CPU impact other than the throughput of loading that much data off of your disk, running it through your CPU and out to OBS. That does technically use CPU and memory to some capacity, on top of using up your drive speed a little bit. The system only really has SATA SSDs. They're not super fast, nothing fancy, nothing, too crazy. And I was able to put the graphics on a SATA SSD and call them up in OBS. And again, as long as it wasn't a full-size scene with lossless AVI, I had no issues. I did test GoPro Cineform as well, and it spiked CPU usage sometimes to 100%. And regardless, it had an issue with the data rates in that it was still playing the graphics slow-mo, even if it wasn't dropping any frames in OBS and CPU usage wasn't pegged to 100%. It was still not playing the graphic at full speed. And I think this has to do with FFmpeg's Cineform implementation. I just don't think it's great at the moment, and OBS is always running on an older version of FFmpeg in the first place. Hopefully with upcoming updates, they can upgrade that FFmpeg instance, but either way, it just would not play back. And so unfortunately, as much as I love Cineform, I can basically just say that outright, it is completely useless for this scenario. An interesting scenario where this kind of confirmed that to me, as I mentioned, if you play like a full screen, be right back screen or something, in lossless AVI, the data rate gets way too high and it bogs down. However, after you've played it 2 or 3 times, it actually catches up. And so after you've played it 2 or 3 times, when you switch to that scene again, it's all cached within OBS. It's already been decoded and plays back just fine. This is not the case with the Cineform file, which means something really wacky is going on. That being said, even if you cache it and stuff, you could still run into issues when you switch scene and it just decided to get rid of the cache or something. So I wouldn't recommend using AVI for those files anyway. Back to stinger transitions. So that rules GoPro Cineform out altogether. We're just gonna throw that codec out. So that leaves us with lossless AVI, ProRes with alpha, and VP9 with alpha. In terms of the hierarchy of CPU usage, they are the reverse of that order. So VP9 of these 3 codecs, VP9 typically on this CPU would use the most CPU to decode. Generally speaking, it was fine. It didn't have any too big of an issue, although I did feel it impacting my actual game performance as I was playing. But it wasn't skipping frames or dropping frames, but it was peaking CPU usage up in the 70s and 80s percent usage by using these files, both as a lower third and switching scenes with it with a stinger transition. Switching over to ProRes with Alpha, drop that from 70 to 80 to 55 to 70% CPU usage, depending on the game moment, which was significantly lower and ran fine. But there were scenarios whenever I had enough going on and could, in any scenario where I peaked CPU usage, or if I tried to use CPU encoding with X264, then it was just too much and it was either playing too slow or I would actually start hitting encoding lag. So all of these tests were with GPU encoding because this kind of processor isn't really meant for X264. But even with X264 very fast, using the ProRes clips was completely not an option, and using VP9 wasn't even a consideration. Lossless AVI worked best in both of those scenarios. Obviously, ProRes was usable when you're using GPU encoding, but Lossless AVI was still the best performing because there was no added CPU decode performance at all. Whereas using CPU encoding, which it was already not really keeping up with, but where you're completely maxed out on CPU usage, the lossless AVI files for the lower third and the stinger transition had zero troubles playing back. So my recommendation, as much as I think people aren't going to hear it, and people probably aren't even going to consider it due to the file sizes, is that you should use a lossless AVI completely uncompressed, because if you start adding in any sort of compression, your CPU has to decode that, is to actually use uncompressed AVI graphics for your individual smaller graphics on your stream. Make them short and loopable for the on-screen graphics, and for your stingers, still use it as well. And if you're making your graphics yourself, you can export that natively from After Effects or whatever you're making it in. Otherwise, if you're getting your graphics from a place like Nerd or Die, I will have a couple batch scripts, which you can edit in Notepad and see the code for yourself if you don't trust for some reason, but a couple bat files that you can then drag your VP9 clip onto, and it will extract it out to a lossless AVI file that you can then add to OBS as a media source or stinger transition and use to gain performance. So if you're someone who's purchased a package from Nerd or Die and found that it's adding some performance penalty to your system or doing something you don't like, you can use these scripts to convert it to AVI and probably get some better performance out of it. Nerd or Die can't distribute these files natively, most likely, because they are just too big. Like a single stinger transition out of an entire package being a full gigabyte is just a massive file size inflation from the 100 megs or something total they distribute anyway, probably less than that. So this is a way to kind of squeeze that extra performance out of graphics you're already receiving from someone else or Nerd or Die. I wanted to make a note with the scripts. There will be two different ones. One is specifically for VP9, because that is what Nerd or Die currently distributes, and that requires a specific decoder flag to actually get the alpha to work. But then I will have a separate script that's for general clips that are in other codecs, so ProRes or QuickTime animation or something like that, which by the way also did not perform well in OBS. And that one will convert to AVI with alpha as well, but the VP9 one has to have a specific piece of FFmpeg code in there. So to use this script, you will need to put the FFmpeg exe either in your path, in your system path. If you don't know what that means, then put the exe in the same folder as the bat file, and then drag your clip onto the bat file, and it will spit out the AVI version along with it. If you have any questions about the script or how to use it, join us on Discord at discord.gg/EposVox. Conclusion time for those who have been struggling to follow what is a fairly technical video. If you're having performance problems when it comes to your media sources for on-screen graphics that have transparency, you need to convert them or otherwise re-render them with lossless AVI with alpha channel enabled, as this will give you the best performance outright, but they will be very big files and you need to have them on a SSD, even a SATA SSD, in order for them to perform the best. If you have a full screen graphic that doesn't have alpha transparency, then you can use H.264 or VP9 and get wonderful hardware decoding and be off to the races regardless. But yeah, I've gotten this question many times, many times over the years, and I have tinkered with experimenting with it off and on over the past couple years as I've wanted to figure it out for myself, because especially as I've moved to doing 4K streams on YouTube for my streamer news show and things like that, I've run into scenarios where the WebM graphics just kind of freak out. Or actually, we had a stream a couple weeks ago where the graphics were literally making like blue screen sounds and freaking everyone out because it was like stalling whenever it went to load the audio. I think that was related to network drives more so than this, but I'm always looking into this, and I finally have what I consider to be like the ultimate answer. And unfortunately, it's kind of a barbaric answer in that you need to use one of the oldest formats and, you know, bulkiest formats ever, but that seems to be the best way to go if you are truly CPU limited and need that extra performance of decoding your sources. So hopefully this video was helpful to someone. Like I said, there's not a lot of people who will want to make this sacrifice in terms of file space, but for someone like me who wants the best performance, 100% worth it. And on my processors, I get to use ProRes with Alpha anyway. So like I said, if you're on a Ryzen 3600 or up, and this will depend on your game and whatever you're streaming anyway and how much CPU that uses. But generally speaking, if you're on a Ryzen 3600 or up, or a Intel Core i5, you know, like a newer one or up, or especially on X299 or Threadripper, then you can use ProRes with Alpha and be totally fine. On much older or lower end CPUs, you may struggle depending on the game with ProRes, and I would recommend Lossless AVI instead. Hope you enjoyed today's video. Hit the like button if you did. Subscribe for more tech education and stream guides. I'm your stream professor, EposVox. I'll see you next time.